So we're doing this question on numerical solutions. The diagram shows a sector OAB of a circle with center O and radius R. The angle AOB is alpha radians, where alpha is between 0 to pi by 2. The point N on OA is such that BN is perpendicular to OA. The area of the triangle ONB is half of the area of sector OAB. Show that alpha satisfies this equation, sine 2x is equals to x. Okay, so we're told area of the triangle ONB. Let's first find an expression for area of the triangle ONB. It's a right angle triangle, so we will do half times base times height to get its area. And base in terms of r and alpha is going to be r cos alpha. And Bn in terms of r and alpha is going to be r sine alpha. I've applied trigonometric ratios in this triangle. Okay, so now area is half times base times height. That's the area of the triangle, which is half of the area of sector. Area of sector is half r square theta. Now let's simplify this. 1 by 4 r square cos alpha sine alpha equals 1 by 4 r square alpha. Cancelling 1 by 4 r square on both sides, we get alpha equals cos alpha sine alpha. I just spotted a mistake that this was 2. So we have a 2 here and we have a 4 here. Now I can cancel the r square and r square. The 4 will go to the other side, become 4 over 2. So there's a 2 here. So 2 cos alpha sine alpha is actually sine 2 alpha is equals to alpha. And they've replaced alpha with x. So we're going to write sine 2 x equals to x. What's wrong with the board? Give me a second, please. Okay, so sine x sine 2x equals to x and hence shown. Part 2. By sketching a suitable pair of graphs, show that this equation has exactly one root in this interval. All right. So we're going to plot the graph for sine 2x in the interval 0 to half pi. First, I'm going to quickly revise what the graph of sine x looks like. It looks like this, between 1 and -1. And for sine 2x, we have 2 cycles completing within 0 to 2 pi period. So that means this would be pi. So for sine x, sine 2x, a full cycle completes at pi, but our domain is only till pi by half. So we're just going to draw this much of it. This would be pi by 2. That's 1 here. Now on the same sketch, we have to draw the line y is equals to x. So let me see what is pi by 2. Pi by 2 is 1.57. So here's pi by 2, 1.57. This would be 2 and 1.57 would roughly be somewhere over here. And this would be the line y is equals to x. And one point of intersection, make a small cross at the point of intersection and write the concluding statement that one point of intersection shows that there's one root in the interval 0 to pi by 2. That concluding statement is important. Okay. Part 3 says that we have to use the initial value 1 and use this given iterative formula to find the exact root. Okay, so x1 is given 1. For x2, we write the iterative formula sine 2 times, write 1 here. But in your calculator, you're going to press 1 and then equals to sign. That will store 1 in the answer key. And then you will write answer key in the calculator. So I'm pressing make sure the calculator is set in radians first. So 1 equals to, that has stored 1 in my answer key. Now sine 2 times answer gives 0.909. So x2 is 0.9093. They did not ask for any particular level of accuracy for every iteration, so we're going to stick to 4 decimal places. For x3, you just press equals to in the calculator. It gives you the value of the next iteration. Then x4, press equals to 0.9330, press equals to again 0.9330, then again 0.9330. So our answer has stopped changing. That means the root is here. Correct to 2 decimal places, x is equals to 0.93. Now hold on, I think something has gone wrong because the answer is 0.95. Let me do this again. So let me just clear all this clutter. Okay, so 1 equals to answer. Now my calculator has 1 stored in the answer key. Then I'm going to do sine. I think I forgot 2 earlier. 2 times answer. And the result of first iteration is 0.9093. For the next iteration is 0.9694, balki 0.9695. Next is 0.9330. Next is, okay, so for some reason, I was not pressing equals to when I thought I was. Okay, next iteration is 0.9567. Press equals to again. Next iteration is 0.9419. Next is 0.9514. Press equals to again 0.9453. Then 0.9492. Okay, now I'll write dot 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 and press equals to a couple of times till the answer stops changing. Now it becomes 0.9774, and then the rounded off answer, it's still changing, I believe. No, it's not. So this is, sorry, 0.9474. And then the final answer correct to 2 decimal places is going to be 0.95. This is alpha.